All right, let's take a look at our lesson on roots and zeros. The first part is we're going to talk about the fundamental theorem of algebra. That sounds like a really big deal, right? Fundamental theorem of algebra. Basically, what it tells us is that if we count up all the complex and repeated solutions, remember, let's talk about the word solutions. Let's kind of break this apart. So solutions means, that's one way to write it. You could say roots. You could say zeros. And in some cases, if it's real, you could say x-intercepts. Okay, solutions, roots, zeros, x-intercepts. If you count them all up, an nth degree polynomial will have exactly n solutions. So for example, this is a fourth degree polynomial, so this one will have 4 solutions. And this is a fifth degree polynomial, so it will have 5 solutions. So it basically just gives us guidelines, or a rule, so we know how many solutions we're looking for. Okay, so that's what the fundamental theorem of algebra says. And talking about vocabulary, we're really big into vocabulary, because if you don't know the words that I'm saying, you won't know what it means, what to do. So K, these 3 things mean the same thing. So K is a 0 of the polynomial function f. X minus K is a factor of polynomial f. And K is a solution of the polynomial equation f equals 0. So those all are talking about the same thing. Factors are like the bubbles we've talked about. I'm calling them bubbles because I like bubbles. Why not? So factors are the bubbles, and K is just a number. It's a 0, which means a 0, a root, an intercept, a solution. Okay? So let's practice. Let's do some problems. The first problem asks us to solve. We want to solve this equation, state the number and types of roots. Now, I'm always going to prefer factoring if possible. I would much rather factor. I know some of you probably think I've lost my mind, but really it's the most straightforward, quickest way to handle it versus some of the other techniques that we have. So if we look at this, it's 2 terms, so it's a binomial, and so it's a subtraction. So this could be the difference of squares or the difference of cubes. As we're looking at it, 16 is a perfect square, x to the 4th is a perfect square, and 625 is also a perfect square, so we're going with the difference of perfect squares. So let's factor. That would be 4x squared minus 25 and 4x squared plus 25 equals 0. Okay, that looks good. And interestingly enough, I have another difference of perfect squares, that 4x squared minus 25. I can break that down even further to 2x minus 5, 2x plus 5, and then I've got my 4x squared plus 25. Okay, so we set each of the bubbles or factors equal to 0. 2x minus 5 is 0, 2x plus 5 is 0, 4x squared plus 25 is 0. Okay, so let's work on these 2 on the left. So 2x would be 5, or x would be 5 halves. Then we have 2x would be negative 5, or x would be negative 5 halves. So let's keep track. So I have 1 solution here, 1 solution here. I'm supposed to have 4. So I have 2 more. The other 2 I'm going to get from here. Now this is a quadratic, and since it's a fairly straightforward, really small, like a little binomial quadratic, we have a particular way that we like to solve these, and that's basically solve for x squared. So move the 25 over, divide both sides by 4. So I have x squared is negative 25 fourths. Then I square root both sides. I have x equals plus or minus. Look at there is a negative in there, so it's an I. Square root of 25 is 5. Square root of 4 is 2. So I have plus or minus 5 halves I, and that accounts for the other two solutions. So we have found all four solutions. Okay, let's go to our next example. Now in this one we're supposed to find 5 solutions. Let's kind of look at it, see what we got going on. I always want to try to factor out a GCF, a greatest common factor, and I do. I've got an x, so I'm going to pull that out. That leaves me x to the 4th minus 8x squared plus 16. Okay, that looks good. So x to the 4th minus 8x squared plus 16. That's a trinomial. So I need to think about what kind of factoring patterns do I have for trinomials. I have that factor like, if it's in quadratic form. If you recall, quadratic form is basically the first exponent has to be double the second one, and it has to have being added just a constant, just some number. So if a, this case, a is 2, so yeah, this is in quadratic form. So we can factor this like FOIL, like a quadratic, with our guess and check technique. X squared, let's see, our back signs are positive, so our signs are going to be the same. We got lots of options for 16. Why don't we try 4 and 4? That seems reasonable. So I have negative 4 squared minus 4 squared gives me negative 8 squared, so that's correct. Okay, so I have options. I could continue factoring that x squared minus 4. Why not? That seems fun. So this is the difference of perfect squares. Okay, this one gave me this. Then I have another difference of perfects, the same one. That's nice. Okay, okay, here we go. So I would set each factor, which is a bubble, where bubbles are factors, equal to 0. So x minus 2 is 0, x plus 2 is 0, x plus 2 is 0, and x minus 2 is 0. Okay, so now I've got, let's see, I've got x equals 0, it's one of them, x is 2, x is negative 2, x is negative 2, and x is 2. So here I've got something called repeated factors. See how these two, I've got a x minus 2, that's just a repeated factor. And I have these two that are repeated. And so when we have repeated factors, we have a little technique that we use called multiplicity. So what we would say is, in this particular case, we have one solution, x equals 0. I have a solution of x equals 2 with multiplicity of 2, which means I have that same factor twice. Multiplicity just means how many of them do you have. If I wanted to do that whole multiplicity vocab word, I have x equals 0 with a multiplicity, what do you think it would be? Yeah, multiplicity of 1. And then I have x equals negative 2 with a multiplicity, and sometimes you can abbreviate it, mult of 2. So that accounts for all 5 of my solutions. Okay, now let's move to the second page and do a little bit more work on this lesson. We have another theorem to talk about. Yay! We've actually already kind of talked about this before. When we have one imaginary solution, we always have 2, right? They never are by themselves, they go in pairs. So if one solution is like a plus bi, then its conjugate is also a solution, a minus bi. So for example, if I had one solution of 2 plus, let's say, 3i, then I would have another one of 2 minus 3i. They go hand in hand. The same thing with the roots. So in this case, a plus square root of b, a minus square root of b. So let's say we've got a solution of 2 plus square root of 3. If 2 plus square root of 3 is this is just an example. If 2 plus square root of 3 is a root, then so is 2 minus square root of 3. So those little guys always go together in pairs. Okay, so let's look at this last example. They want us to write a polynomial function of least degree. That means, you know, just least degree. Don't you love it when that happens? Come on, you can go back. Okay. Least degree means that, you know, if you can write it as an x squared, you wouldn't write it as an x cubed. You want to write it as the least degree. That's what that word means. Rational coefficients means you can't have like imaginary numbers. That's not okay. Leading coefficient of 1, we've talked about that before, where the leading coefficient is the term with the highest exponent, and that number in front of it should be a 1. All right, so let's look at this. So they're trying to be tricky with us here. Look at there. Look at this little guy. 4 plus 2i. Okay, well, if I have a 4 plus 2i, I also have a 4 minus 2i. Okay, so I have that. And if I have a 1 plus root 7, I also have a 1 minus root 7. So I actually have 5 zeros. I have 3, I have 4 plus 2i, 4 minus 2i, 1 plus root 7, 1 minus root 7. I have 5 different zeros. So we're going to use our little formula, x squared minus sum x plus product, to help us generate this polynomial. And I'm going to use it on the pairs, like the 4 plus 2i, 4 minus 2i. So we do the sum. So I'm going to do 4 plus 2i plus 4 minus 2i, and that gives me 8. Then we do the product, and that is 4 plus 2i times 4 minus 2i. Okay, so let's multiply that together. So 4 times 4 is 16. Inside, outside go away. That's the beauty of the conjugate. Minus 4i squared. We know that 16 minus 4 times negative 1, because I squared is negative 1. Let's see, what does that give us? That gives us 20. Okay, so let's write that. Let's come over here. Let's write that polynomial. So x squared minus sum x plus product. Okay, that's 1 of, that will generate the zeros 4 plus 2i, 4 minus 2i. And while we're at it, we might as well write down the factor that generates the 3. That would be x minus 3. Okay, very good. So we've got one more pair to work with. And this pair, I'm going to use this same x squared minus sum x plus product. So this is quite a handy formula to help us with these difficult problems, like with the imaginaries and the radicals. Okay, so here we go. Let's do it again. So I've got the sum of 1 plus root 7 plus 1 minus root 7, and that's 2. Then I have the product of 1 plus root 7 times 1 minus root 7. Let's see, so let's FOIL that out. That gives me 1, and then the outside inside go away because, you know, it's they're conjugates. Root 7 times root 7 is 7. So that gives me, that turns into being negative 6. Okay, so let's write that quadratic up here. So x squared minus sum x minus 2x plus product, so plus a negative 6 would be just minus 6. Whew, okay, we made it this far. This is great. We have our factored polynomial. This is the factored one. Okay, but unfortunately we can't leave it in that form. That's not okay. So we're going to have to, yes, you guessed it, we're going to have to multiply all that out. Oh, and it's misbehaving. Oh well, I won't try to move it. So what I'm going to do is I'm going to multiply these two together first, and we'll get that, and then we'll keep working on. This is going to be a lot of multiplying, guys. It's going to be fantastic. Okay, here we go. So I'm going to take the x and multiply it by all of this. So x times x squared is x cubed. X times negative 8x is negative 8x squared. X times 20 is 20x. Okay, now let's do the negative 3. Let's do that, 3 times. Negative 3 times x squared is negative 3x squared. Negative 3 times a negative 8 is a positive 24x. And negative 3 times 20 is what? Negative 60. Okay, that stays in a parenthesis. And now I want to clean it up. I want to make it much more easy to work with. There's a lot going on there. So when I clean that up, let's see, what do I get? I get x cubed. Let's just kind of do some color coding. So I've got the squares to work with. I've got the regular x's to work with. Okay. So negative 8x squared minus 3x squared is what? Negative 11x squared. Okay. Then I've got 20x plus 24x. That's a 44x. And then we've got our minus 60. Whew, I told you this is going to be a little bit crazy. A little bit crazy. Now we've got some major multiplying to do, right? Look at that. Doesn't that look so fantastic? Whew. Okay, so let's take the x cubed and multiply it by all the back ones. So here we go. We can do this. X cubed times x squared is x to the 5th. X cubed times negative 2x is negative 2x to the 4th. X cubed times negative 6 is negative 6x cubed. Whew, I'm done with that one. Okay, now let's move to the negative 11x squared. Okay, negative 11x squared times x squared is negative 11x to the 4th. Negative 11x squared times a negative 2x is a positive 22x cubed. Okay, making our way. A negative 11x squared times a negative 6 is a positive 66x squared. Whew, finished with that one. Okay, we got this. A couple more. So 44x times x squared would give us 44x cubed. 44x times negative 2x is negative 88x squared. Okay, 44x times a negative 6. Oh my goodness. So let's see, 44 times 6. 64 is 24, 26. So minus 264x. Whew, okay. Done with the 44, thankfully, right? Now the 60, oh gosh, big numbers. You guys know big numbers drive me crazy. Okay, so that's okay. Negative 60 times x squared is negative 60x squared. Negative 60 times a negative 2, okay, that's plus 120x. And then 60 times 6 would be 360. Goodness gracious. All right, so we really need to do some color coding here. Okay, so, well, I only have one x to the 5th, so I don't need to color code it, but I've got some 4s. There's a 4. Okay, there's only 4s I have. Let's look at some 3s. I've got cubes here. Okay. Let's look at, oops, I missed a cube. There's another cube. Okay, let's look at squares. So we've got this one and this one and this one. Oh, it's a lot to keep up with, guys. And let's look at just plain old x's. Got 2 of those and just one constant. Okay, we can do it. So x to the 5th, yay. So let's look, negative 2x to the 4th minus 11x to the 4th. That would give me a negative 13x to the 4th. Okay, good. Now let's look at the green ones. So what do I have? I have negative 6 plus 22. So negative 6 plus 22 plus 44 what would that give me? That's 66 minus 6, so 60. 60x cubed. Okay, let's work on the squares. I've got 66 minus 88 minus 60. Let's see, the 66 minus 60 would give me 6. So what is that, negative 82 x squareds. Okay, so now let's look at the plain old x's. I've got negative 264 plus 120. Negative 264 plus 120. That would give me a negative 144x. Whew, we're almost there. Plus 360. And that is the end of that problem. All right, fantastic.